this thing called the primitive function. How do we go backwards, I guess, is the question. See, we've got the equation of a curve and we want to find the equation of the tangent. How do we go back the other way? Because every mathematical operation has an inverse. It goes one way, goes back the other way, return it. So if we do know the equation of the tangent, how do we find out what the original curve was? To start off with, this is purely for polynomials, of course, x to the power of n, then the primitive function would become this. X to the n plus 1 over n plus 1, or as the way I think about it is add 1 to the power over the power. So if I know the derivative is 3x to the power of 4, it must have come from add 1 to the power 5 over the power 5. But you'll notice I've also put this plus a constant number, because of course when you differentiate a constant, you get 0. And therefore, if in the thing I'm finding the primitive function of, I've got nothing, it might have come from something. So I need plus a constant. Here's a cubic, but what did it come from? So each one of those, add 1 to the power over that power and tidy up where I can. Well, looks like just the first one tidies up, doesn't it? So there we go, with 3 over 2 x to the power of 4 plus 5 over 3x cubed plus half x squared plus 2x plus, of course, a constant. Alright, well let's now look at that. So what is the equation of a curve which passes through the point 1, 1? Has a gradient function. Gradient function. Well, that's just a fancy way of saying the derivative, because it is the function that finds the gradient. So basically they're telling me the derivative is 2x plus 3. Okay, I know dy dx is 2x plus 3. I want to find its primitive. The technical name for this, by the way, is the integrand. So integrand, and we go from the integrand to find the primitive function itself. Add 1 to the power over the power. I didn't bother writing 2 over 2 in this case. I did the cancelling straight away. And then the 3 became 3x plus a constant. So what we're saying is there's a whole series of curves, a family if you like, which all have a gradient function of 2x plus 3. They would be parabolas, x squared plus 3x plus a constant. Well, what does the plus a constant mean? Well, that, if you think about it, is a vertical shift. So we can move that parabola up and down anywhere we like, but at any x value, every one of those curves, it would have the same slope. We're interested in the particular one that goes through the point 1, 1. So let's substitute in. We know when x equals 1, y equals 1. Playing around with that, we get what our constant value is for this particular situation. Negative 3. There is our parabola. X squared plus 3x minus 3. Okay. That shall do this.